Sometimes when we're talking about these sets, it's nice to have a graphical way to represent them, and this is where Venn diagrams come in handy. So I have three different Venn diagrams here, three different possibilities. First off, you can see we're talking about two sets, A and B, and when I have these two sets, if I kind of partially overlap them, well, I guess I also have U, I should point that out. U here, the universal set, is the big box that goes around the outside. This is, again, the whole point of the universal set is to give me some sort of boundaries, to say that everything we're talking about in this problem exists somewhere within U. So if we're talking about A and B as our sets, and we kind of partially overlap them like this, then you can see we end up with four different possible regions. We can have elements. We could say that something is outside both A and B by putting it out here. Let's say we have an alpha floating out here. Okay, well, alpha would be both outside A and B. You could have something in here. You could have, let's go with beta. We could have a beta that's both in A and in B, because it's in the overlapping region between the two of them. You could have a, let's go, do I want to keep going Greek alphabet? Whatever, let's go X. You could have an X that is in the set of A, but it's not in the set of B. You can see it's within the circle where I've drawn A, so it's within A, but it's not within B. And then finally, you could have a Y over here, where it's shown as, just graphically, you can see it's within B, it's within the set B, but it's not in the set A. So this would be the part of the point of drawing up a Venn diagram like this. There are a couple of different things when we're talking about Venn diagrams and we write something on here. There's a couple of different meanings that could be meant. You could be labeling the numbers, labeling the regions, so I could refer to them as regions 1, 2, 3, and 4. You could be talking about these as being individual elements within each of these regions. So this 1, instead of being a label 1, this could be representing a 1 within this region, just like the alpha I was saying was within this region. And the 2 could be, 2 itself might not be the name of the region, it might be an element within this. So you need to be clear, you need to understand what's meant when you're looking at a Venn diagram. The other possible meaning is this could be referring to the number of elements within this particular region. So this could be saying that there's one thing floating somewhere out here. If there's a 2 in here, it could be because there's an X and a Z. So there could be 2 elements within there. If this is a 3, it could be because there's a beta and a gamma and a delta. There's 3 individual elements within there, and here we have a Y, and we also have an A, B, C, lowercase a, b, c. So these, when you see numbers or when you see the labels on here, make sure you understand what they mean. Depending on the example you're looking at, it may change. Alright, so in any case, let's look at the next example of, another Venn diagram we might see. If you draw the A and the B, so that they're not overlapping at all, this actually implies that their intersection is empty. This would be a way to represent that A and B are disjoint. Or disjoint here. Because there's nothing common between them. This does say the numbering is arbitrary, so this is kind of labeling the individual regions. At least that was the intention here. So you can see there actually only ends up being 3 different regions, because the region of, this is implying that there's no elements that are in common between the two of them. This example right here, we have, it looks like A is entirely nested within B. And so this one actually implies that A is a subset of B. And I'm saying a subset rather than a proper subset because there's no guarantee that there's any elements within in this region 2. If there is an element within region 2, then you can actually get a little bit stronger here, and you can say A is a proper subset of B. But given just what I have here, the 1, 2, and 3 are just region numbers. I would say that this is about as strong as that implication can get. And in general, when we're talking about Venn diagrams with 2 sets, you'll want to just use this way, this first version. It's the most generic. It doesn't imply anything, and so you can use it in all circumstances. If you're using 3 different sets, how we tend to draw the Venn diagrams is like this. You can see we did the A and the B partially overlapping, and then the C goes through, this is the area where they intersect, C kind of goes right through there. And we actually end up with 8 individual regions when we're talking about a Venn diagram like this. Most of the time, for the purposes of this class, most of the time when we're drawing numbers on here, it will either be region numbers, region names, kind of like what's done here, 1, 2, 3, 4, 5, or it'll be talking about the size of those regions. So yeah, make sure you understand what is meant when you're looking at a particular problem.